Hello everyone, and today we'll be seeing one of the problem from lead code. It says n repeated elements in size to an array. Now the problem goes like, okay, so cool. The problem goes like, you are given an integer array nums with the following properties, which is nums.length is equal to 2 into n. So we are sure that nums.length is always an even number because it's always multiplied by 2 with an integer number. Nums contains n plus 1 unique elements. That means n plus 1 unique elements, and there might be rest might be duplicated. And there is also second thing, third item, which is exactly one element of nums is repeated n times. Nice. So only one element is repeated. That's very good because that makes our life much more simpler now. Return the element that is repeated n times. Awesome. So we wanted to return the number which is element which is repeated n times. You see, rest are not repeated, so it makes sense that number is repeating n times. So it's no brainer. Now you have three numbers which says n plus 1, n is 2 in this case. 2 plus 1 are unique elements, which is unique elements 1, 2, 3, and rest are 3, 3, which is repeating n times, which is repeating 2 times, which is n verifies, and that's the reason 3 is output. Same here with example number 2, where you see 2 is the repeating element, and same with example number 5, you see 5 is a repeating element. The constraint is very simple. Any no follow-ups for this? Okay, that's weird. Usually such kind of problems have a follow-up, like they wanted to solve this in O of n time complexity. Well, I have few submissions for this, but I'll come to those submissions later. First of all, I'll discuss few of the approach where what we can do over here. Obviously, one can go ahead and say that, hey, what I'll try to do is I'll just do a brute force approach. Brute force approach where I will do for element I in array and for element in I to end of array, a of I to end, a of all array. I wanted to find that, hey, and this I'll call it as x, this I will call it as y, and I wanted to just check that if x is equal to y or not. Then if it is, return x or y, whatever, because both are same. Y, x or y would suffice. That's a good one, because you see every other element is a unique element. Even if you find one single occurrence, that if you find that, hey, 2 is occurring 2 times, then you are sure that, hey, 2 is the resultant answer which we want. So that is a shortcut over here, or that's a common sense, I would say, over here. But one would say, hey, brute force is like time complexity is O of n square, you know, so n into n, n into n. So you don't want that. Can you do better? Can you do better for this? Obviously, the space complexity is O of 1. So we can say that, hey, we can use space here, and we can use set or hash map anywhere. Hash map. So that would give us, and the implementation is quite simple. That time complexity would be O of where is O? O of 1 n, and space complexity would, however, be O of n as well. Can we improve this upon? Again, yes, again we can improve this. We can do one thing, that we can change the array, modify the array. So instead of having any extra space, I would use the array to denote how I can store directly within, how I can use the current array as hash map. If you are unaware of this concept is very simple. I have explained this within the previous video. You can go ahead and check the video over here. Here would be somewhere the link. But again, if someone goes ahead, and the problem with such kind of easy questions is that it feels like very easy, but you are thrown with a multiple constraints within an interview. Within a real interview, interviewer says that, hey, let's assume that it's a multi-threaded system and you don't want to alter the existing array. So constraint, no altering the array. So cool, I don't want even to alter the array. By the way, the time complexity of this solution was O of n, and the space complexity was O of 1. Sorry, my bad. O of 1. Can we do better? Can we do better without modifying an array? Cool. For that, we need to go back into understanding what the question is. The question is very much simple, that we have array like this, where or to this, or you have array like 1, 2, 3, 3. So you see, this is a pattern which we follow. Here the array elements or the repeating elements are twice repeating, and here you see the repeating elements are 3 times repeating. Here, although there is a clear partition that beyond this point you had repeated elements, so this entire thing is a repetition, but you don't have such kind of things. You had one repetition over here, next you had repetition over here, and next you have directly over here. So how can you do? But one thing is so sure for us, that array is of size n, 2n, sorry, and repetition is n. So this is a clear indication that we'll have either a best case or the worst case. I'll say the best case first. Best case is you have n items right at the start, and then you have rest of the array, or you have rest of the array and n items right at the end. Something very similar to example number 1. If I'm at this, my iterator is at this point, I would just check, hey, 3 is matching with the next 3, so 3 is a duplicate. So even if element occurs twice, I can return this. Cool. That's a intuition, and that's a best case. But worst case solution is n is spread across. So you have n, repeating number, non-repeating number. Then you have repeating number, non-repeating number, repeating, non-repeating, repeating, non-repeating, and so on. That is spread across, that we mean. So even if I go ahead, my iterator checks that, hey, am I repeating with you, it will say as false. And when my iterator comes over this point, it will check with a number front of it. It will say not. And this way, that's the worst condition for us. Can we optimize that one? Can we tackle that one? Can we tackle this one in such a way that we can get a good answer even if we hit with a worst case scenario? Obviously, we can do that. We have just need to do one thing, that we have to erase one element from the picture, which is this. Now we have erased this one element, we are left with an array of size n minus 1. Now there are two things with us. Either the element we ignored was repeating, was target, I will say, else target is in the rest of list. There can be anything. So if the element was ignored and within the target, then this is a case where let our iterator check that element, check that ignore. So if my iterator comes into any of the element, let's say this is size, let's say my iterator comes over here. So here is my iterator. I'll say I as iterator. Let me check this element with the ignored element. If it is equal, then good, return that. If it is not equal, increment it. So if it is equal, good, we found it, return it. So in this way, we are sure that, hey, if the ignored element was target, I am covered, man. But if my ignored element is not the target, and my target is somewhere hiding within this n minus 1 size of list, what can I do? Then in that case, what could I do is I need to check for the repetition within the n minus 1. Now this is a rephrasing. What does it mean, by the way? So if it is n minus 1 and I'm having repeating elements and repeating elements are n, then I'm sure to have, sorry, the size is 2n minus 1. Okay, this is 2n minus 1 because this array is of size 2n and we remove one element. So 2n minus 1 and repeating is n element. So that means after every one point I can see there is a next iterator. So it is something very similar to, like, you have how many, say, I would say like 5 seats and 3 people, and you are given a 5 seat. Let's imagine like this: you have 5 seats and 3 people. So how would you let them sit? So you would sit in this way, or else you would let them sit in this way, or else you would let them sit in any of the way. So, but the thing is, you are making that person at least in a way that it would repeat itself, or it would repeat with the first element. You understand? I'm within the check, and I'm within the check. I'm saying for here I'm dealing with 2n minus 1 elements, and I am finding n elements. Cool. So either this, that, you can do the permutation and you are free to do that, man. So this, and this, you can get any of the iterations. The idea behind this is either your element is repeating or not. That's the whole point of this problem, and that can be done by considering not one but next 2 elements. That's the one case. Else you initially choose 2 elements. So this is another case. I'll do both of them. I'll do the second one and I'll tell you how you can do the first one. Don't worry if you didn't got the solution right. Once we'll code, you'll get the solution. So I'll quickly rename this as a int n1 and n2. These are 2 elements I'm choosing. N1 is the one element I'm going to ignore, a of 0. Then we have n2, which is the next element, which is a of 1. So for int I is equal to either it's 0, 1 or what, I'll take it plus 2. Why? Because 0 is covered, 1 is covered. I'll improve my loop and I'll start from 2. I is less than a dot length and I plus plus. Now I'll